We have already learned how to determine the properties of pure substances during phase change processes and those of ideal gases. In this presentation, we will learn how to calculate changes in the specific internal energy and the specific enthalpy of incompressible substances. An incompressible substance is one whose density or specific volume is constant. Liquids and solids can be approximated as incompressible substances. It has been shown mathematically that for incompressible substances, the specific heats at constant volume and the specific heats at constant pressure are identical. They are simply referred to as the specific heat, C. Recall that the specific heat at constant volume can be expressed as the derivative of the specific internal energy with respect to temperature. Like those of ideal gases, the specific heats of incompressible substances depend on temperature only. So the partial derivative can be replaced with an ordinary derivative. This equation can be separated and integrated as follows. The integral on the left side simply becomes the change in the specific internal energy during the process. The specific heat at constant volume becomes the specific heat. So changes in the specific internal energy of incompressible substances can be found by integrating the specific heat with respect to temperature over the process. Recall that the definition of the specific enthalpy is the specific internal energy plus the product of the specific volume and the pressure. We can differentiate this equation to find the change in specific enthalpy. We use the product rule on the PV term. For incompressible substances, the change in the specific volume dV is 0, so the last term in this equation goes away. We now integrate this equation from one state to another. Because the specific volume of incompressible substances is constant, the last integral becomes the specific volume times the change in pressure. So the change in specific enthalpy of incompressible substances is simply equal to the change in specific internal energy plus the product of the specific volume and the change in pressure during the process.